All right, so here's how I did this. All right, so then you can call these vectors anything you want. Doesn't matter if you used any variable names, or even if you just didn't have anything on the left-hand side, it'll just by default make this, put it in a default variable called ANS for answer. All right, so the first one, I just listed the numbers separated by commas, or I could have just used spaces, and you can mix the two, it doesn't matter. Second one, row vector starting at -3, steps of 3 up to 12. It's just a matter of making sure you get them in the right order. Third one, since in this case we know how many elements we want, it's better to use linspace. That way MATLAB will calculate the step size for you. In this case, it comes out to be a very uneven step size. All right, and then the second one, or the second part. So this is a column vector, so we separate it by semicolons instead. Or again, you could put the numbers on separate lines if you want. And I have 2.5 pets because we have a feral cat who lives outside that we feed every day. So he's sort of a pet and sort of not. And then the last one, I wanted to take that previous row vector that I made and turn it into a column vector. So I use the transpose operator. All right, any questions about that? All right, very good. All right, so those are 1D arrays or vectors. It can be row vectors, column vectors. You can also make 2D arrays. In fact, you can even make as many dimensions as you want. But in this class, with one small exception near the end, we only do 2D arrays. All right, so a 2D array in MATLAB, they also call a matrix. So here's an example of making a matrix. And the example I came up with, I wanted to make something realistic as opposed to just arbitrary numbers. So let's say you're programming a chess game and you want to make a representation of the board. Well, you could do a matrix. And let's say the scheme you use is 1 is a pawn, 2 is a knight, 3 is a bishop, and so forth. And then positive numbers can be black, negative could be white. And a 0 means there's no piece on that square. And so you just list the numbers again, all the numbers in one row separated by commas or spaces, and then you put a semicolon to go to the next row. Right, so kind of combining the syntax for row and column vectors. All right, and we get this matrix. You can also use the techniques that we showed previously for making vectors, like the colon operator or linspace, and then combine them. So the term is concatenation, concatenating those vectors to build up a matrix. So let's say we wanted to make this matrix, but instead of just typing in all the numbers, we wanted to do it more succinctly using the colon operator and linspace. So here are 2 different ways you could do that. The first one does it row by row. You can see the first row is the numbers 1 through 4. And notice I didn't put a step size here. If you leave out a step size, it defaults to 1. Right, so you don't have to put a 1. You could, but if the step size is 1, you can just leave it out. Second row is steps of 2, going 2, 4, 6, 8. And the third one is using linspace. So it'll be 4 items, 4 numbers, starting at 3, going up to 12. So that'll be 3, 6, 9, 12. And the second time, I did it column by column instead. All right, so pay attention because you're going to use this in the exercise in a few minutes. All right, so I want to take each of these sets of numbers, and to make it a column, I take the transpose of each one of them, and then I assemble them side by side to make a matrix. All right, so good rule of thumb to keep in mind. When you separate them by semicolons, that puts one on top of the other. When you separate them by commas or spaces, that puts one beside the other. All right, so 2 different ways of making that matrix. Now, there's some built-in functions that are handy for creating matrices, especially initializing matrices. Ones, zeros, rand to make random numbers, and rand_i, which makes random integers. All right, so this is saying, give me a 1×4 array, in other words, a row vector with 4 numbers in it of ones. This says, give me a 5×1 array, which is a column of 5 numbers, 5 rows, 1 column of zeros. This says, give me a 4×4 matrix of random numbers, or strictly speaking, pseudo-random numbers between 0 and 1. And this says, give me a 2×3 matrix of random integers between 1 and 100. That's what the first number is, it's the upper limit. All right, so you see I got an array of 4 ones, a column vector of 5 zeros, 4×4 matrix of pseudo-random numbers between 0 and 1, and then a 2×3 matrix of integers all between 1 and 100. So random number generators are good for games or Monte Carlo simulations. And if you were to watch my recording from yesterday's class, you would see exactly the same numbers here, because they're not truly random, they're pseudo-random. And every time you restart MATLAB, the pseudo-random number generator is going to start in the same place. Okay? So unless you seed the random number generator, every time you stop and restart MATLAB, you'll actually get the same sequence of numbers. All right, so using those techniques, here's a more succinct way of doing the chessboard. Right, so instead of listing all of these ones and zeros, I can use the ones and zeros functions. Okay, so I put the first row, and the second row is all ones. The next 4 rows are all zeros, so I can just make that a matrix, 4×8. Then the next row is minus ones, so I can use ones and then multiply by -1. We'll talk more about doing operations on vectors next time. And then the last row. All right, so it created that same matrix as before, but just in a more succinct way. All right, so I'll just give you 2 minutes for this one. This one is very simple. Just try creating a couple of matrices.